Indexing. Indexing. This is the most important topic in SQL for data analyst people. In every interview, there will be 100% questions from this particular topic called indexing. What is a index? When it comes to index, index is also a database object which is used to improve the performance of the query. Index will improve the speed or performance of the query. Index is a database object like table, view, stored procedure. Index is also one of the database objects which is used to improve the performance of the query. Which is used to improve the performance of query. In a normal query, for example, I have a table with single column called serial number. I have a table name is table only, with only one column called serial number. In this particular column, I have a sequence of numbers from 1 to 10. Now, if I want to print only one particular number called 6, tell me a query to print the number called 6. Tell me a query to print number called 6 from this particular table. Select star from table name is table. That's why I will write table. Table. Now I want to print only 6. Yeah, where serial number equal to 6. Where serial number equal to 6. The query is same everywhere, but whenever we are using normal where condition, what it will do means, this where condition will filter the data, right? It will go to the table, it will go to the column called serial number. It will search whether 1 is equal to 6. Will this condition satisfy? 1 is equal to 6? No, condition failed. Then it will go to 2. It will check whether 2 is equal to 6. Condition failed. It will go to 3. It will check whether 3 is equal to 6. No. Whether 4 is equal to 6. No. Whether 5 is equal to 6. No. 6 is equal to 6. Now the condition satisfies and it will print the value called 6. It will search for a value like this. If you want to print the value called 6, how many steps it is taking? 6 steps. We have to include the correct statement also. It is taking 6 steps. Only to find the value called 6. What if you have sequence of 1 crore values and if you want to print one particular value? I have sequence of 1 crore values and I want to print a value called 60 lakhs. How many steps it will take? It will take 60 lakhs steps. To find the value called 6, it can print in less than 1 second. But to search 60 lakhs times, will it take more time or not? It will definitely take more time. For example, when it comes to your bank or something, how many users will be there for any bank? Let us consider State Bank of India. How many users will be there? Let us consider 5 to 10 crore users will be there throughout India. 10 crore users are there. If one person is opening any application like GPay, PhonePe or something, or he opens that banking application, own banking application, and he tried to print his current balance. He tried to get his current balance. What it will do is, it will go to banking table and it will go to the current balance column and it will search for his account ID first, where account ID is equal to that particular account ID, and it will print his current balance. This is going to happen. If there are 10 crore customers, how much time it will take to print only his current balance? Only 1% current balance. It is taking 10, if his account ID is something around 60 lakhs, it will take 60 lakh steps. How much time it will take? For example, let us consider SQL is very quick. It can filter 1 lakh data within a seconds. Can filter lakhs of data in seconds. Even though to filter value from 10 crore details or to filter one particular value from 10 crore records, it will definitely take 1 or 2 minutes time. 1 or 2 minutes time to filter one particular value, because it has to search in 10 crore values. Isn't it possible to take 1 or 2 minutes time to search for a value in 10 crore records? Even it is a programming language, to search value by value, it will take a lot of time, right? For finding a value called 6, how many steps it is taking? 6 steps. I am asking you to consider that there are 10 crore values, sequence of 10 crore values. This is sequence of 10 crore value. I want to find some value, one value in between. Let me consider this particular value is something around 6 crores. How many steps it will take to find that particular value? It will take 6 crore steps, right? Okay. How much time it will take to fetch this particular value? As SQL is very quick, it can filter 1 lakh or 2 lakh records in seconds only. Even if we consider it as very quick application, it will take 1 or 2 minutes to find this particular value called 6 crores. Yes or no? Because it is searching value by value. Value by value. For example, if you try to fetch current balance or balance in your banking application and it is loading for 2 minutes, will you accept it? Why? No one will accept. First, with that irritation, they will break their own mobile. If it is taking 2 or 3 minutes, or if it is taking 5 minutes, there are a lot of records, right? First, it has to search for one particular person data and it has to fetch his current balance. There are crores of records present in bank. If it is taking 5 minutes, we can't wait for it. That's why what we have to do is, we have to improve the searching performance of the query. We have to improve the searching performance of the query. To improve the performance of the query, we have a topic called indexing. When it comes to this indexing, based on search criteria, this index will be given for column, which is used for searching. For example, if you want to search account details of one particular person, which column is used to search? Account ID column is, by using account ID, we will search for his details, right? We will write index on account ID column. Like that, for based on any searching column, we will write an index to improve that search criteria. Based on the search criteria, we have three types of indexes. They are B-tree index, hash index, and R-tree index. B tree index, hash index, and arbitrary index. Manaki three types of we are going to have these three types of indexes based on search criteria. Let us see how this B tree index will works. This B tree is also called as balanced tree. Balanced tree. B tree is also called as balanced tree. For example, I have a value sequence of values between 1 and 100. I have sequence of values between 1 and 100. And I want to find the value called 67. How much time will it take to find the value by using normal where condition? It will take 67 steps to find the value based on normal where condition. But what this B tree index will do means, first it will take the center value. This particular value is called node value. Node value. It will take one center value. What is the center value between 1 and 100? 50. 50 is the node value for this. It will take this center value and it will search in such a way like that whether 67 is less than or equal to 50 or greater than 50. 67 greater than 50. This condition satisfies. It will not search in first 50 values now. 67 is not there in first 50 values. It will skip first 50 values. Now what it will do means, it will again balance the data which is called 50 and 100. What will be the node value between 50 and 100? 75. 50 and 100. From where 25 will comes between 75 is the node value. Will search whether 67 is less than or equal to 75 or greater than 70. Sixty-seven is less than or equal to 75, right? 67 is between 50 and 75. It is less than or equal to 75. This condition satisfies. And it will not search for any value above 70. It will skip the next values wherever the condition fails. Now it will balance again between 50 and 70. What will be the between value? 63. Let me consider 62 or 63. It will check whether 67 is less than or equal to 63 or greater than 63. 67 is greater than 63. Then it will not search for the values between 50 and 63. It will again balance 63 and 75. What will be the middle value? 60, almost 67 will be the middle value. 67 or 68 will be the middle value. Okay, let us consider 67. And the value got matched finally. Even if it is 68, it will take one more step to balance again and it will match the value. Let us consider this value is 67. And value got matched successfully. How many steps is it taking to find the value called 67? One step, two step, three step, third step, fourth step. Even if you consider one more step, one or two steps more taken to balance again, 5 and 6 steps. It is taking 6 steps to find the value called 67. Find the value called 67 by balancing the data and by using the node value. It is finding the value called 67 within 6 or 7 steps, 5 or 6 steps. Now, which process is better, whether using normal where condition or based on B-tree index? If we are using this particular search criteria of B-tree index, will it fetch the data quickly or not? It will print the data very quickly. Here itself, in our scenario, it is improving at least 10 times speed. If you have lot of values or if you have crores of records, this B-tree index will improve the performance up to 1000 times. It will improve the performance of the query up to 1000 times. B-tree index will improve the performance of the query up to 1000 times. By balancing the data, it will find the value very quickly. This is one type of search criteria. After that, we have one more index called hash index. Hash index. What this hash index will do is, this hash index can find any value in single step. This B-tree index, for finding a value called 67, this B-tree index is taking 6 steps, right? This hash index can find any value in single step. Now, which index is quicker, B-tree index or hash index? Hash index is quicker. Even if you have 1 crore value, it will fetch the details only in single step. What this hash index will do means, it will store the path of each and every value. It will store the path of each value or each record. For example, for anything that we are storing in our computer, we will have some path for it. For example, if I am going to some random if I am storing some anything, any file or anything in my computer, everything will be stored in some folder. That particular file, each and every file will have some path. Yes or no? Some path will be there for each and every file. Even if we are storing any SQL thing, it will be stored in some hard disk. For each and every value, there will be some path. It will be assigned some storage, and for storage, there will be some path. What this hash index will do is, this hash index will store this path. It will copy this path. It will store that particular path of each and every value. Now I have storage path of that particular file, which I open now. If I have that particular path, I need not to take multiple steps to open that particular folder now. What I will do is, I will just click on home and I will paste that path. If I click on enter, directly I can go to that folder in single step. Without taking multiple steps, if I have path of that particular value, I can go there in single step. This hash index will store the path of each and every value and retrieve the data in single step. But there are a lot of disadvantages of this hash index. To store the path of each and every value, this hash index will consume lot of storage again. It is storing the path of each and every value, right? To store that values, it needs additional memory again. It will consume lot of storage. If you create hash index for the on a large data or on large number of records, it may lead to the failure of your storage engine. It may lead to the failure of your storage space. Storage engine or storage space. May leads to the failure of storage engine. By default, SQL will take B-tree index. Default index in SQL is B-tree index. By default, SQL will take B-tree index. And we have one more type of index called R-tree index, which is also called as random forest tree. Random forest tree. Random forest tree. The workability of this R-tree index will also be same as B-tree index. It will also divide values and it will also search for one particular value using node value, and it will fetch the data very quickly. In some steps, in 5 or 6 steps, it will fetch for some particular value. But what is the difference between B-tree index and R-tree index? R-tree index will work for multi-dimensional data. Multi-dimensional data. Here, B-tree index will work for normal value. Multi-dimensional value means 1.23, any fractional or decimal value. This B-tree index will work for normal integer value. If you have any multi-dimensional value, this R-tree index will be useful. If you are searching based on a multi-dimensional value, R-tree index will be useful. If you are using any exact integer value, then you have to take B-tree index. Like 30 degrees, 25 minutes, 60 seconds. If you have any multi-dimensional values, 1 kilometer, 20 meters, and 6 centimeters. Like this, if you have very accurate or multi-dimensional values, we will use the type of index called R-tree index. For the data types called float, double, decimal, whatever it might be, we will use R-tree index. These are the types of indexes that we have based on such criteria. We have B-tree index, which will balance the data and fetch for single value and search for the value. And we have hash index, which will fetch any value in single step, but it will store the path of each and every value. That's why it will consume a lot of storage. Whenever we are creating hash index in our system, it will give us a warning, which is called your storage engine will fail. Because our storage engine or our system computer engine will not have elasticity. Elasticity means we should be able to increase the storage immediately whenever it is required. If you are using any cloud, if there is any data increasing, you can increase the storage immediately, which is present in the cloud. You can pay some more amount to the cloud provider and you can increase the storage immediately. Whereas in our system, it is not possible, right? If you are storing more content, it is not possible to expand storage or it is not possible to reduce storage whenever it is required. Is it possible in our system? We can, but immediately we can't do, right? We can't expand and we can't reduce immediately, right? We need to purchase a lot of hardware and we have to install it. That is also a limited storage. Even if we want to increase storage, again we have to purchase. We have to purchase hardware and we have to install it. When it comes to cloud, it will not be like that. It is expandable. If you have any storage increment, it will increase automatically. It is online storage, right? Cloud is an online storage, which is provided by some other cloud providers like Azure or AWS or something. It will increase immediately. There we will have elasticity of storage. If you want additional storage, you can purchase immediately and storage will be increased. Here we don't have such option like that. That's why hash index will not support for our storage engine. That's why it will throw us a warning. Warning means hash is used sometimes whenever we are using cloud and whenever we have small number of records. For example, we have records like 200 or 300 records. Even if we are adding records, we might consider, we estimated that the maximum records will be 500. More than that, number of records are not going to increase. Then we can use hash index. If we have crores of records, and even though that crores of records are multiplying day by day, then you can't use hash index. We have to use B-tree index. This is the symbol for warning. A triangle symbol will come in yellow color. If query is executed successfully, green color tick mark will come. If query is error, red color into mark will come. Red color into mark will come if you have any error in the query. If there is any warning, it will show in yellow color triangle symbol like a danger board. Not only for storage, if you have any warnings in SQL syntax, it will show this yellow color triangle symbol. Based on the search criteria, we have three types of indexes. Based on the type of column which we are using, we have some types of indexes. Based on the type of column, we have few types of indexes based on the type of column. I already told you we will write index on one particular column. We will write index on particular column, which that particular column should be useful for searching the data. For example, here based on the type of columns, we have two types of indexes called clustered index and non-clustered index. Clustered index and non-clustered index. clustered index and non-clustered index. If we are writing a index on a primary key column, we are writing a index on a primary key column, it will be called as a clustered index. If we are writing any index on account ID column, which index will it become? Account ID is primary key, right? Which index will it become? Clustered index. If we are writing any index on non-primary key column, it will become non-clustered index. For example, I am writing index on transaction details table, and I wrote index on account ID column in transaction details table. Account ID column in transaction details table is foreign, it is not primary key. Then it will become non-clustered index. If a index is written on primary key column, it is called as a clustered index. If we are writing index on any non-primary key column, it will be called as a non-clustered index. This will be the most asked interview question. 70% of the time in interviews, they will ask you what is the difference between clustered and non-clustered index. If we are writing index on a primary key column, it will be called as a clustered index. If we are writing index on a non-primary key column, it will be called as a non-clustered index. Again, based on the data type of the column, we have few types of indexes. Based on the data type of the column, we have few indexes. Indexes, these are called as data types of indexes. We have unique index, full text index, and spatial index. Unique index, full text index, and spatial index. When it comes to unique index, this unique index will accept the values of integer, character, or varchar. But this column should contain only unique values. This column should not have any duplicate values. This unique int will accept the values of data types called integer, character, and varchar. And these columns of integer data type or character data type or varchar data type should have only unique values, not have any duplicate values. Then only we can use unique index. This unique index will accept integer data types or character data types or varchar. Then what is the purpose of full text index means? This char and varchar will store the maximum length of the text, which is called 255. If you are searching for a value which contains text more than 255 letters, then what you have to do? You have to go to the type of index called full text index. This full text index will be used for lengthy text or long text. The text which contain more than 255 characters are for text data type values. For text data type values, we will use the index called full text index. After that, we have one more data type of the index, which is called spatial. This spatial is used for multi-dimensional values or fractional values. Multi-dimensional values or fractional values. based on the type of column we are choosing, we have to use this data type and name of the index. Let me explain you the syntax for creating index. We learned about a very long theory, right? Let me explain you the syntax. Syntax will be smaller than normal select. Create index, index name, create index, index name. If you want, you can write in single line also. Create index, index name on table name of column name. Table name of column name. This is the syntax for index. If you want to create index on account ID column in account details table, what will be the query? If you want to create index on account ID column in account details table, what will be the syntax? We can give any name. Create index, account ID index on account details of account ID. That's all. By default, if you write a query like this, by default, which index will be taken by SQL? What is the default index of SQL? By default, SQL will take B3 index, right? If you write this particular query, SQL will take B3 index. After that, if you want to mention that I am taking index for this specified data type like that, you have to mention this data type. You can write it here. After create, you can mention create unique or full text or spatial. No, we need not to use bracket as these are optional values I am giving in bracket. You can mention create unique index or create full text index or create spatial index name. Create unique index name on table name of column name. We can write like this. This is an optional value. We need not to mention this data type. Even if you don't mention, index will be created. If you want to mention, you can mention also. After that, by default, SQL is taking B3 index. If you want to create hash index, how can you create? Create index data type, index name. After index name, you have to mention using B3 or hash or R3. You have to mention this. Using B3 or using hash or using R3. Which type of index do you want to choose? If you don't mention anything, by default SQL will create normal B3 index. If you want to create unique index of B3 type, you have to write create unique index name using B3 on table name of column name. No, we have to just write normal. Create unique or create full text or create spatial normally. As these are optional values to indicate I mentioned in bracket. We have to mention any one of these, unique or full text or spatial. Yeah, create index name using hash on table name of column. Using hash. If you want to B3, you have to mention using B tree. If you want R3, you have to mention using R3. If you expand in your database, if you expand tables, and if you expand your account details table, there will be some options called columns, indexes, foreign keys, and triggers. If you expand indexes, by default, primary key will be there as index. Only primary key column will be there as index. We can't zoom this text. It's not possible to do application text. If you want, I can zoom the query. Here, if in your system, you can expand the database. And if you expand the tables again, if you expand any tables, there will be option called indexes. If you expand that indexes, if there is any primary key or foreign primary key value or any foreign key value, it will be shown as index by default. Now, if I want to create any index, what I have to do is, for example, on account details table, I want to create index on account ID column. What I will do? Create index. Index name is account ID index. Account ID index on account details of account ID. Create index name on table name of column. If I execute this particular query, and if I refresh schemas, here in indexes, I have one more index called account ID. I got, before this, I have only primary as index. Now I have one more index called account ID index. I have one more index called account ID index. If I want to remove this index, for removing any database object from database, what is the command that we have? Drop. If you want to remove the table from database, you have to use drop table name. If you want to drop index, you have to write drop index name. Drop index account ID index. Any database objects. Let's review. View. If you want to drop view, you have to write drop view name. Drop view name. When it comes to index, you have to, only for index, you have to mention table name also. Drop index name on table name. Because index will be separate, index, even if index is a database object, it will be created separately on a table. Separately for one column in a table. Drop index name on table. If I don't mention anything, by default, SQL will take B tree as index, right? I will drop this particular index. This index is dropped successfully. After that, in the same query, I will write using hash. Create index name using hash. Now I want to create hash index. I already told you, if you try to create hash index, it will throw you error. If you try to create hash index, sorry, it will throw you warning. It will throw you a warning like storage engine will fail. If I try to create hash index, a yellow color triangle symbol will be there, and the warning is 0 affected, one warning. Got one warning. It is not a error. It is warning. Query got executed successfully, but it is showing warning. Yellow color triangle symbol. Yeah, no problem. You can read the message called this storage engine does not support hash index algorithm. The storage space you are using default storage, it will not support hash index methodologies. If you want to drop, you can drop hash index. If you use B-tree index, it will not throw any error. If storage is not the issue for you, you can ignore it. It is already executed successfully, but it is giving you warning, a intimation, like you are using hash index, your storage engine might fail quickly. If you are using a lot of data, your storage file will fail quickly. Then we have to check it. Where we are storing it. You want to check whether index is created or not. Yes. Here you can search. I dropped this index now. No index is created. If I refresh this, only I have one primary. You can check here. Only in indexes, only I have primary. I don't have any other indexes. Here I want to create using hash. And if I execute this particular query, if I refresh here near indexes, see, I have one more index called account ID index. Two indexes are. We can check. It is throwing us the warning. Storage problem is not there for us. It is giving us the warning. If you use hash index will consume lot of storage. To storage each and path of each and every value, consume lot of storage. If you are using hash index, it will consume lot of storage and your storage will fail quickly. That is the warning. Storage is not there, we can't execute any other index also. Storage is not there, anything we can't insert value also. Everything will fail. Inserting value also will fail. If storage is not there, you can't do anything on the database. Right? To store anything, you should have storage. But it is giving warning. In future, you will get problems if you are using hash index. It should intimate you, right? It should inform you. Otherwise, you don't know what are the effects of hash index. Hash index will consume a lot of storage. Now you have only 1 lakh records in your table. After 1 year, it might become 10 lakhs records. You might insert, you might get few more customers and you might add their data also. If your data is keep on increasing, this hash index will keep on increasing its consumption of storage also. Correct, right? It will take additional, if it is taking additional storage, you can't estimate how much storage it is taking. Your storage will complete quickly. If you are taking B-tree index will not take any storage. By using some algorithm, it will balance the values and it will search for the data. Whereas hash index is storing the path of each and every value. it may lead to the failure of storage. It is the warning. It is not the error. These are the types of indexes that we have. Even if you want to mention, you can mention data type also. Create unique index, or create full text index, or create spatial index. This will be the complete query. Even if you don't mention this unique and all, it is not a problem. If you want to remove the index, you have to use drop index name or table name. On drop upon title text if the column or key exists. Okay, I already dropped this particular index. Yeah. What is this? If you want to mention data type for the index, based on the data type, we have three types of indexes: unique, full text, and spatial. This unique index is used for integer, character, and varchar values of unique columns, of a columns which contain only unique values. Unique values will be present in columns which have only primary key or unique as a constraint. Only for those two columns we are going to have unique values. In any other columns we will have duplicate values. In that particular scenario, we are going to use unique index for integer, character, or varchar. If you want to use full text index, it is used for the lengthy text. If you are using spatial index, it is used for multidimensional or fractional values. You can mention data type. These are optional things. Mentioning data types and type of index is optional things. If you just write create index name on table name of column name, by default SQL will take B3 index, which is normally used. For index, there will be no output. It will just change the search criteria. That's all. You will write normal select query only. Select star from table name where ID is equal to 6 or 7. Index will not print the output. Index will change the search criteria. Index will increase the performance of the query. Query is normal. Normal where condition, how it is searching? It is searching value by value, right? Value by value, one by one. If you are creating B3 index, after that, if you search for any value, it will not search value by value. It will balance the data using node value and it will search in a different format. Yeah. Yeah. No. If we create once, it will be used for multiple times. If we create table only once, we are printing the data every time, right? Like that, index also will be created only once.